Hi, welcome to the Mathemagic channel. Today we look at finding all the positive values of n for which n squared plus 45 gives you a perfect square. This is a math counts question. Really fun little problem, a few skills involved. Let's try it out. So this is a really fun problem, and we can see that if we were to put n equals 2 in the equation, well, n squared would be 4, 4 plus 45 is 49, so 2 seems like a good solution just by looking at it, but there might be more, right? So why not use a little bit of algebra to see if we can get there? So it's pretty much the same thing as saying n squared plus 45 is equal to x squared. Moving those values, moving the n squared to the right, we can say 45 equals x squared minus n squared. And there's a formula that's going to be pretty useful here, which is the difference of two squares. So if you see that on the right hand side, you have a squared minus b squared. We can say that that's a plus b, factor of a minus b. And so as we factorize the right hand side, we can change it into 45 equals x plus n, factor of x minus n. So this is quite interesting. We're now looking for pairs of factors of 45. And remember, we're only looking for integer values, so whole number values. Now luckily 45 doesn't have that many factor pairs. It has 1 times 45. It has 3 times 15. And what else do we have? We also have 5 and 9, right? So we can say 5 times 9. And I think that's pretty much it. There might be 3 factor pairs for 45. We can check this from a prime factorization, but this is pretty fine. So if we continue with our work here, we can think about x plus n and x minus n being equal to 1 times 45, or being equal to 3 times 15, or 5 times 9, remembering that we're using whole number values. And it's important to note that the value x plus n, since we're adding whole positive numbers, that value is going to be greater than x minus n. Naturally, if you were to take a value x, so the perfect square that you have, and add n to it, which is a positive number, that'll be bigger than if you subtract n from it. So you can set the sum of the numbers to be equal to the larger factor. So we can say, for example, that x plus n would be equal to 45, while x minus n is equal to 1. And so this is a good way to start with the first bit, with 45 and 1. And using simultaneous equations here, you can add the two lines to each other, and you can get to 2x equal 46, which leads you to the answer x equal 23. And so if you think about x being 23, what does that give us for n? Well, we know that x minus n is equal to 1, so that would give you a value of n, which is 22, right? So in this case, n would be equal to 22. Well, that's a solution we didn't see from just looking at the problem, so that's a good one to add in. So we can take the same logic here with x plus n equal 15 and x minus n equal 3. And adding these two equations together, we're going to get 2x equal 18, and that'll lead you to a value of x, which is 9. And if the x value is 9, and we say that x minus n is 3, so let's think about this for a second. X minus n being 3, that'll give you an n value, which is 6. So we also have the numbers x equal 9 and n equal 6. And I guess finally what you can do is you can look at the solutions with 5 and 9, right? So we could say x plus n. So let's do a system of two equations again. So x plus n is equal to 9. X minus n is equal to 5. And that leads you to 2x being equal to, so 9 plus 5 is 14. And then x will be 7. And if we do 7 minus n is 5, we'll get n equal 2, which is the solution we first found by just looking at the problem. So in the end, it looks like we have three solutions: n equal 22, n equal 6, n equal 2. Well, we looked at 2 and we're pretty happy with 2 squared being 4. 4 plus 45 is 49, so we get a perfect square, which is 7 squared. With 6, So 6 squared is 36, 36 and 45 is 81, so 81 is the perfect square for 9. And for 22, that's definitely one which we would have had issues finding. But if you check it, 22 squared is 484. And if you were to add 484 to 45, you get 529. And 529, you can check that, that is 23 squared. So that works for all three of these solutions, and we're pretty happy. Thank you for watching the Mathemagic channel and doing this question with us today. Challenge yourself with more MathCounts and Math Olympiad questions. So we'll post some as regularly as we can, but if you want, you should go and practice some past papers. These are pretty good if you're doing math competitions. They're also very challenging for the mind, and they bring in like a bunch of different techniques. Here, for example, we use the difference of two squares, we use prime factorizations, or factor pairs rather. And then we're able to solve systems of two equations with two unknowns. So there are really three different skills coming through. And it's also good to know your perfect squares up to 100. So we could say that there are 4 key skills in this question which are coming through. So always good to have a well-rounded understanding for mathematics. So thank you for watching the channel, and we shall see you on the next one. Click the like and subscribe button to support us. We appreciate it. Bye-bye.